Okay, so this is a part of the video, part of a series where we're trying to build LLM from scratch, specifically GPT-2. Okay, so in the previous videos, you have seen how we tokenize the text and how we, convert those tokens into numerical. Each of these tokens gets some numerical value, some integer value, unique integer value. Okay, so now the next step is to do some kind of embedding, something called embedding. So embedding is basically turning these integer tokens into some continuous vector representation. Okay, so that's what we're going to do in this video. So our data is almost ready to feed into an LLM. Okay, so but lastly, so we need to embed the tokens, these integer tokens that we created in the previous step. Okay, so in a continuous vector representation using something called embedding layer, which is a neural network, of course. Okay, a layer of neural network. So usually these embedding layers are part of the LLM itself, and they're updated. That is, they also trained that the weights of those embedding layers are updated. That is trained when the model is trained. Okay, so here you can see in this picture. Let's see. So far, we have done. So this is the input text. So these three steps we have already done in the previous videos. Okay. So here you can see this is an example. Is an example text, right? Input text. So we tokenize that text, that sentence, into words and punctuation, right? So this is an example that's been tokenized here, and then there's tokenized. Each of those tokens get some integer ID, which are called token IDs, and here they are. And then so we've done these three things in the previous videos, right? So now in this in this one, what we're gonna do is we're gonna take we're gonna embed each of these token IDs into some continuous vector representation. So each of these, so this one will be turned into some vector, converted into some vector, okay, represented as some vector, some fixed dimensional, vector. They are all the same size vectors, okay. So this is what we're going to do, and then after that, we're ready to input the, they feed these inputs, these token embeddings into the GPT, this model LLM. Okay. All right. So let's see. So suppose we have the following 4 input examples with 2, 3, 5, and 1. So we have, say for example, we have these 4 token IDs, right? So 2, 3, 5, 1 are the token IDs, okay, which we have turned them into tensor, torus tensor, PyTorch tensor, okay. And then for the sake of simplicity, suppose we have a small vocabulary. So let's say for this example, we're gonna we're gonna assume we're gonna suppose that there are only 6 words, total of 6 words in our vocabulary, and then the output dimension, the dimension of each of those is 3, right? When we turn them into a vector, okay. So each word or token, 6 of these, okay, they'll be turned into a 3-dimensional vector. Okay, so here this is for reproducibility, okay, seeding. Okay, over here, so we're going to use this embedding layer, torus.nn.embedding, and then these are the dimensions we give, the vocab size and the output dimension. Okay, so now what this does is it returns or gives us this tensor right here, so which is 6 by 3, right? So for example, these are all the words in our tokens in our vocabulary, which we said 6, right? So these are 6 of them, and each of them have been turned into some kind of turned into a vector, 3-dimensional vector, as you can see here, right? So it's a 6 by 3, okay, 6 by 3 matrix, okay. So it's something like now here what we're going to do is something kind of like one-hot encoding. Okay, so This is pretty much like a one-hot encoding. Okay, so which I will do a video later. Okay, the difference between embedding and this matrix multiplication. Okay, so all right, so this embedding layer is just a more efficient implementation. Okay, that is equivalent to the one-hot encoding and the matrix multiplication approach. Okay, so I'll create another video on this one. Okay, so now to convert a token with the into token with the three with ID 3 into a three-dimensional vector. So what we're going to do is, so for example, you have a token which has ID of 3. So we want to embed that token with the input the token ID 3. Okay, so this is how we're going to do it. So embedding layer, which we created up there, this is the embedding layer. Embedding layer, and then what you do is you pass to it torch.tensor3, and this will give you this vector, right, three-dimensional vector. And if you go back and look over here, so that's the vector at the index 3. See, this is index 0, index 1, index 2, and this is index 3, right, as you can see here. And this is exactly the same vector right here. Okay, all right, so likewise, now let's try to embed this one right here, this input IDs, which consist of 4 input tokens, 2, 3, 5, 1, right? So this is how we're going to do it. See, now what we're going to do is embedding layer, which we created up there, right? So we pass the input IDs, this tensor, input IDs tensor, and it will give us this 4 vectors, 4 three-dimensional vectors, right? So these are just, it's pretty simple. See, so for example, here the tensor is 2, 3, 5, 1. So first one is 2, right? So you go to the index 2 of this embedding layer, 1, 0, 1, 2. This is 1.2753, this one. Okay, starting with 1.2753, and that is it right here. Okay, the next one is 3, right? So 3, the embedding of 3 is what? 3 is 0, 1, 2, 3, minus 0.45, starting with minus 0.45, which is this one, and so on. Okay, and it's pretty clear from this picture right here. So you can see there. So these are the tokens to be embedded, right? And all it does is it does a lookup on this embedding layer, right? For example, 5, then it goes to index 5, the row index 5 of the weight matrix of embedding layer, okay? And just it returns that, and then the corresponding embedding of 5. The embedding of 5 is this one, this 5th, the index row index 5 of the embedding layer. And likewise for say 3, same thing. 3 is 0, 1, 2, 3, and this is the embedding. Okay, all right. So